Alright, so today we're going to be doing our last operations that we're going to be doing with radicals, which is adding and subtracting. So the operations with radicals are very similar to how we do operations with fractions. So when we were multiplying and dividing the square roots the other day or last week, we could just if both the numbers were inside the square root, we could just multiply them together and simplify. If they were if the division was happening, both of them were in a square root, we could do the division and then simplify. Just like with fractions, you could go straight across, same change flip. Multiplication and division is pretty straightforward. With adding and subtracting, however, it's similar to how we add and subtract fractions, where we had to find a common denominator with fractions in order to add or subtract. With adding and subtracting square roots, we have to find a common number under the square root, or a common radicand. This is similar to adding and subtracting fractions. Where you need the same number under the square root to add. So to do that, you're going to start by simplifying your square roots as much as possible. And then once you've simplified as much as possible, any of your terms that have the same number under that square root, you can, if they're being added. So if you had like a square root of b plus c square root of b, you would be able to just take your numbers outside of the parentheses, so that a plus c, and add them together. And the square root of b just comes along. Just like when we were doing adding and subtracting fractions, you add or subtract the numerators, and the denominator stays the same. It's kind of the same idea. You add and subtract the numbers out in front, and the square root stays the same. Or if we're subtracting, if you're subtracting, it would be the same idea. You would subtract the numbers out in front, and the number in the square root would just come along for the ride. Okay, so simplify as much as possible, and then you're combining those common square roots, so the numbers that, or the square roots that have the same number under the root, under the radical. Okay, so for an example 1, so the first thing we want to do is look at all of our terms, all of our square roots, and make sure they are as simplified as possible. So remember, when we're simplifying, we first ask ourselves if we can evaluate it. That's where if you were to do square root of, in this case, like square root of 2 in your calculator, it would give you a nice number. That would be evaluating. So we have in letter A, we have 2 square root 2's, and we have 2 square root 3's. Can either of those be evaluated? No. So then we ask ourselves our second question, which is wait, I didn't finish the question. Can any perfect squares go into the number under the square root? So can any perfect squares go into 2 or 3? No. So that means they are as simplified as much as possible. So if the answer is no to both of these, then you've simplified as far as you can. So that now that we are simplified, if we look at what we're left with, we can only add together the terms that have the same number under the square root. So we have this 7 square root of 2 plus 5 square root of 2. Those both have that square root of 2. And we have 2 square root of 3 minus 6 square root of 3. They both have the square root of 3. So if we look at our first ones, our square root of 2's, We have 7 square root 2 plus 5 square root 2. We can take our numbers out in front, add those together, and the square root of 2 just follows along. This is like saying we have 7 root 2's and we add 5 more root 2's, which will leave us with 12 root 2's. Well, that was the first part. We have to deal with the square root 3's now. So with our square root 3's, we have 2 minus 6 square root 3. So 2 minus 6 would give us a negative 4. If we add a negative, because we're adding a negative 4, what's that the same as doing? Subtracting. So we could just write it as 12 square root 2 minus 4 square root 3. And now with these, with what we're left with here, this is a square root 2 and that's a square root 3. Those are two different numbers under square root, so we cannot combine them any further. This would be our final answer. Okay, that one was pretty straightforward because you didn't have to do any simplifying at the beginning. So do you guys have any questions? All right, let's take a look at letter B. So we have square root 2 plus square root 8. So we first have to simplify as much as possible. So with square root, we'll start with square root 2. Can we evaluate it? No. Can any perfect squares go into it? No, so we're stuck with square root 2. If we look at square root 8, can we evaluate square root 8?
Yes.
We can evaluate it? No, but can any perfect squares go into 8?
Yeah.
Yes. What perfect square? 4. So we can rewrite this as, we'll have our square root of 2, that just is going to carry along so we don't forget about it. And we have plus square root of 4 times 2. That's the same as saying 8. We're just splitting it up, writing it as a multiplication problem. And then using our product rule that we used last week, we can write this as square root of 4 times square root of 2 as 2 square roots. And then looking at our square roots one at a time, can we evaluate square root of 4? Maybe, yes. It will give us 2. So we'll have our square root 2 plus 2 square root 2. Because can we evaluate this square root 2? This one? No. Can any perfect squares go into 2? No. So now we have square root 2 plus 2 square root 2. They both have this square root 2 here, so we can add them together, but there's no number out in front of this square root. What is that implied value out there? 1. Yes, 1. That is an implied 1. So we have 1 square root 2 plus 2 square root 2, so we can do 1 plus 2 square root 2, which will give us 3 square root 2. Okay, so a lot of this stuff that we're doing with radicals here just involves a lot of simplifying. Any questions on letter B? All right. Let's take a look at letter C. Okay, so we have 3 different square roots now. We have a square root of 24, a square root of 6, and a square root of 36. So we're going to go just one by one and simplify them as far as we can. So square root of 24, and we have our 2 questions. Can we evaluate it? If you do square root 24 in your calculator, do you get a nice number? You guys can try it. You'll have calculators sitting in front of you.
Yes.
You can evaluate it?
No, it's just guessing.
Yeah. Well, you have...
12.
No, you can't evaluate it. Can any perfect squares go into 24?
Yes.
Yeah. Well, 4 is the perfect square that can go into 24, and it's 4 times 6. Okay, so then we can split that up as a square root of 4 times the square root of 6. And then square root of 4 is equal to 2. And can we do anything more with the square root of 6? No, so we're stuck with it. All right, that was our first term there. Now if we move on to our second one, we have plus 10 square root 6. So with that square root 6, can we evaluate square root 6? No. Can any perfect squares go into 6? No. So we're stuck with it. So plus 10 square root 6. And then our last one here, minus 3 square root 36. Yes, square root of 36 can be evaluated. If you do square root of 36 in your calculator, you should get 6. This would be negative 3 times, remember, because multiplication is what's happening in between. So times 6, which give us a negative 18, minus 18 down there. Okay, just have to be careful that you're not dropping any negatives or subtraction signs. Make sure that they're staying consistent as you're rewriting all of these. And now we are simplified as much as possible, so now we just need to look for what terms have the same number under the square root. Yeah. Yes, 2 square root 6 plus 10 square root 6. So we can add together those numbers out in front. And the 18, the minus 18 just has to stay there because it doesn't have a square root 6, so it can't join in on the fun. And we can add the 2 and the 10 together to give us 12 square root 6 minus 18. And since no more terms have the same number under the square root, that would be as far as we can go. All right, you guys have any questions? Can you try D and E then? So again, every square root you're going to simplify as much as possible first, and then you can combine any terms with the same number under the square root from there. So go ahead, everybody try D and E. So letter D. The only square root that could be simplified anymore was the square root of 27. So we could have our 5 square root 3 has to stay the same, minus 2. And then the perfect square that can go into 27 is 9. So we split it up as 9 times 3. Use our product rule to write that as 2 square roots. And I'm just copying down the 5 square root 3 and the square root 5 just as we go so I don't forget about them. You don't have to do it every time, but if you keep writing it, then there's a less likely chance that you'll forget about them at the end. And then square root of 9 is equal to 3. And this is multiplication that happens in between a number that's right in front of a square root and the square root. So this would be 2 times 3, square root 3. So we can do that multiplication. Give us minus 6 square root 3. And then the two terms that we can combine are the two with the square root 3's. So 5 square root 3 minus 6 square root 3. Which would give us a negative. You could write either negative 1 square root 3 plus square root 5, or if you want to just write negative square root 3 plus square root 5. That works. It's a personal preference if you want to actually write the 1 or not. Whatever way you want to do it. Okay. Any questions there? Okay, and then our last one, letter D or letter E. Both of these square roots could be broken up. So you should have ended up with 4 times and then 25 times 2 in the square root. So you're going to write that as 2 square roots. And then square root of 25, since 25 is a perfect square, that can be evaluated. So you have 4 times 5 square root 2, which gives us 20 square root 2. That's for the first term. Then we got to do the same thing for our second one. So we have minus 6. And then what is the perfect square that can go into 32? 4. Is there a bigger one? 16. You could do 4. You just have to simplify it a little more again. So 16 is a bigger perfect square, so that'll just mean less simplifying for us. But if you did 4 right off the bat, that's fine. You just have to do another round of simplifying. So they give us minus 6 square root of 16 times square root of 2. Square root of 16 is 4. So minus 24 square root 2. And now, after all that work, we still have to do the subtraction. Both of them now have the square root of 2, so we're allowed to combine them. So we do our subtraction with the numbers out in front. 20 minus 24 square root 2, which will give us a negative 4 square root 2. All right. You guys have any questions? So again, it's a lot of the same thing we've been doing, a lot of simplifying when it comes to doing anything with radicals. So you simplify as much as you can first, and then it's just adding or subtracting the numbers out in front.